good morning dear students, and we have started the chapter number 2, that is IR spectroscopy. In last lecture we have seen the introduction, then electromagnetic radiation, then region where we work for the IR spectroscopy, then frequency, wave number, etc, etc. In second lecture, today we will see the types of vibrations and degree of freedom in detail. We know that every molecule vibrating continuously, vibrations are of a two types, stretching vibrations and bending vibrations. So we will see the types of vibration and degree of freedom today. So let us see the types of vibrations. Molecular vibration we call it as. So vibration means what? Molecule is continuously vibrating. Vibrating means its atoms are changes its length, bond length, and then bond angle. So according to that, two types of vibrations are there. First is a stretching vibration and second is a bending vibration. Now if we draw the molecules, molecules are considered as atoms. Atoms are bounded by a spring, like chemical bond is like a spring. For example, this is one atom bonded to the another two different atom, or it may be the same or maybe the different, depends on the type of molecule. So this bond is like a spring. So that bond is continuously changes its length. It may go forward and again come back. So this kind of motion, this kind of vibration is a stretching vibration. Means this bond length changes continuously. This spring is continuously stretch and come back, stretch and come back. Such a vibration is called as a stretching vibration. So stretching vibration means bond length changes here. Stretching means bond length changes while vibrating. Second type of the vibration is the bending vibration. Bending vibration here again, the two molecules, a molecule where the triatomic molecule is it, and bond angle changes. Bond angle changes, and because of changing bond angle, the motion is obtained to the molecule, and that motion is a vibration motion, and such a kind of vibration is called as a bending vibration. So in bending vibration, bond angle changes. So bond angle changes here. Further, stretching vibrations and bending vibrations are divided into the different types. So stretching vibrations are divided into the two main types. First is a symmetric stretching and second is a asymmetric stretching. We will see later on in details. And bending vibrations are divided into the four types: scissoring, then rocking, wagging and twisting. Now this name is already familiar with it. Scissoring means like a scissor. The motion of the bond, that motion of the bond is like a scissor. And rocking we know the dance steps. Rocking means just shaking our hand by raising the hand. That step is called as a rocking. And wagging means the movement like a honeybee wags to remove the honey from his mouth. So that motion is called as a wagging. And twisting, we know the twisting means crossing the hand by raising it. That motion is called as a twisting. We will see details about each bending vibrations later on. So let us see details about the stretching vibrations first. So stretching vibrations are divided into the two main types, that is symmetric stretching and asymmetric stretching. So name itself indicates symmetric means quite symmetry is present while stretching. So symmetric stretching, consider a bond like this. Carbon is bonded to the hydrogens, and valency of carbon we have to maintain here, that is 4 valency. Only consider these two bonds. These two bonds we have to consider. So stretching here, symmetric stretching means what? These two bonds simultaneously elongate means extend likewise and contract again. That is called as a symmetric stretching. Can show shorten the length again. That is called as a symmetric stretching. Means both the bond elongate simultaneously and get come back simultaneously. That is called as a symmetric stretching. Then second kind of the stretching vibration is asymmetric stretching vibration. While asymmetric stretching vibration, again we can draw the carbon. Here, in case of asymmetric stretching, when one bond elongates, at that time another bond is come back. Means one bond is elongate and another bond is bond length is compressed. Means this called as a asymmetric stretching. And frequency required. If we talk about the frequency, then frequency required for the asymmetric stretching is greater than a symmetric stretching. So frequency required for asymmetric stretching is greater than symmetric stretching. So consider an example, anhydride. Then anhydride, we have to draw the simultaneous both the structures to compare the symmetric and asymmetric stretching of aldehydes. So in first case, these bonds are symmetrically stretched. Both are elongate at a time and get contract at a time. So stretching frequency is almost 1760 per centimeter. While the second case where first bond is elongate and second bond is a compressed, means asymmetric stretching is there, and approx wave number value is 1800 per centimeter. So this is a difference. So asymmetric stretching requires the more frequency as compared to the symmetric stretching. And if we talk about the bending and stretching and bending vibrations, then stretching vibration required more frequency. Stretching vibration require more frequency as compared to bending vibrations. So we can write the frequency required for stretching is greater than frequency required for bending. So next type of vibration is a bending vibration. So bending means what? Bond angle changes between the two bonds. So bending vibrations are divided into the four types. Main four types of the bending vibrations are there. First is the scissoring, then second rocking, wagging and twisting. We already hear these words and these words are very familiar with us. So let us see first scissoring. So scissoring, let's draw the structure. Carbon is hydrogen and hydrogen, complete the valency likewise. So scissoring means what? Our scissor. Regular we use the scissor. So like the scissor, one fork come and another fork come like this, and this action or this motion is called as the scissoring, and where the bond angle is increases and decreases continuously. So the scissoring is the bending vibration. Second one is the rocking. Let us draw the carbon. Two hydrogens here. So rocking. Rocking means what? If we raise our both the hand and move both the hand at a one side at a time and then to the second side with the music, then that steps like a rocking means it just go to the one side, both the bond go to the one side likewise, and here the bond angle is maybe the constant, but the motion means the bond angle, the position is changes, and that is the rocking. So rocking means it is the both the bonds, both the atoms go to the one side, the rocking. Then scissoring and rocking. Scissoring and rocking, this motion, that bending takes place within a plane. So these bending vibrations are called as a in-plane bending vibration. In-plane bending vibration. In-plane bending vibration. Third type of the bending vibration is a wagging. So wagging is the motion done by honeybees to remove the honey from its mouth. So wagging means what? It's a motion where these bonds, these hydrogens come out from the plane and again come back to its original position. That motion is called as a wagging. Means just come out, come back, come out, come back, like a swinging, like a swing. We swing the in the garden. That's like the motion. It is called as a wagging motion. Then twisting. Twisting where the two atoms bonded atoms like this. So one atom come forward and other atom go back likewise. That is the twisting. Twist, just cross means one bond come forward and another come back. So bond angle changes here. This motion is called as a twisting, and this is another kind of the bending vibration. So if we see in the wagging and twisting, then these two vibrations where the bond come out from its plane. So these two vibrations are called as out of plane vibration. Out of plane vibrations. Out of plane vibrations. So question may come on this point MCQ. The scissoring and rocking are the in plane bending vibrations, and wagging and twisting are out of plane vibrations. So these are the types of the molecular vibrations. Molecule vibrates mainly two types: stretching and bending. Stretching, symmetric or asymmetric; bending, scissoring, rocking, wagging and twisting. So next topic is the degree of freedom. We know that the molecule, degree of freedom means the total number of variables used to define the motions of the molecule completely. For example, if we know that in 3D molecules, motion of the molecule in the three-dimensional space, if we describe that the total number of coordinates, each atom is assigned as a set of x, y and z coordinates, and can move in all three directions. Means molecule can move in all three directions, that is x, y and z axis, along the x, y and z axis. So degree of freedom is the total number of the vibrations, not vibrations, the degree of freedom is the total number of variables used to define the motion of molecule. So when molecule is associated with the vibrational motion, then molecule has the translational and rotational motion itself. So if a molecule having the triatomic molecule, if we consider the triatomic molecule, or before considering the triatomic molecule, if molecule molecule has n number of atoms, if a molecule has n number of atoms, then it has a 3n degree of freedom. 3n degree of freedom. Degree of freedom means it's a motion. It can move to 3 directions. So if we see the vibrational modes, then if n number of atoms, n atoms in the molecule has 3n degree of freedom. So 3n degree of freedom. So out of the 3n degree of freedom, 3n degree constitutes the total translation plus rotational plus vibrations. So these are the degree of freedoms are divided. So translation, rotational and vibrational. So translation means molecule travel towards the any axis, means 3. These translation motions are the 3. So for a non-linear, if we consider the first case, that is a non-linear molecule. Non-linear molecule, 3 degree of freedom for the translation. So for the non-linear molecule, translation are the 3 plus rotations. Translation means the 3 degree of freedom for the translation at along motion along the x, y and z directions, and 3 degree of freedom of rotational here, and the remaining are the vibrational. Second, if we consider the linear molecule, non-linear में translation 3, rotational 3 and remaining are the vibrational motions or vibrational degree of freedom. Then linear molecule, if we consider the linear molecule, here in case of the linear molecule, the translation are the 3, rotational are 2 and the remaining are the vibrational. Now here, why rotationals are only 2? Because the rotation of the linear molecule along its molecular axis. For example, this is an molecule, this is an one linear molecule, and its molecular axis is this x, or consider is z axis, it's a molecular axis. Then rotation of this linear molecule along the molecular axis isn't the case, means it come back to the original position, means resultant rotation become a 0. So that's why linear molecule having only 2 degree of rotational freedom and remaining are the vibrational. So non-linear molecules having the 3 translation and 3 rotational and remaining vibrational. So if we have to measure the vibrational degree of freedom, the number of degree of vibrational freedom for non-linear molecule. So total are 3n. Total 3n number of vibration. From the total vibrations, mode of vibration, we have to subtract the translation and rotational. So 3n minus 6 degree of freedom is for non-linear molecule. And for linear molecule, so total number of degree of freedom, total are 3n, and only vibration if you have to count, then from total we have to subtract the rotational and translation from it. So 3n minus 5 degree of vibrational freedom for the non-linear molecule. What does it mean? It means that molecule having that much kind of vibration. stretching and bending vibration. So let us see an example. We will take one example of linear and another for the non-linear. So first is H2O. H2 molecule, we know that the geometry is like this and it is a non-linear molecule. Non-linear molecule. And N means total number of atoms. The total number of atoms are 3 here. And so degree of freedom, number of degree of vibrational freedom, number of degree of vibrational freedom for H2O is equals to 3 into N minus 6 is equal to 3 into 3 minus 6. So 9 minus 6, it comes as a 3. So total 3 number of degree of vibrations are there, means 3 modes. It may be the asymmetric stretching like symmetric stretching 1, then asymmetric stretching, and one may be the bending vibration. So there are total 3 degree of vibration. Second example, if we see, that is carbon dioxide, CO2. Now we know the geometry, it is a linear molecule likewise. So the linear, N is equal to again a 3 here. N is the number of atoms, N is equal to 3. So the number of degree of vibration freedom 3n minus 5 here, because it is a linear molecule. The rotation along the axis is meaningless. So 9 minus 5 is equal to 4 here. So there are total 4 modes of vibrations are present for carbon dioxide. So today we have seen the types of vibration and the degree of freedom, degree of vibrational freedom. So in next lecture we will see the types of band present in the IR spectrum, means overtone, combination band, forbidden bands, etc. etc. Till that time, please share, subscribe and press the bell icon, so whenever I add the new video you will get the notification. Thank you.